Let's just do a few more where we're finding. So we've got this one that's a little trickier to find. So I'm going to go ahead and find the inverse. So we have y equals 3 over x plus 1. So a couple things you could do. I usually just go ahead and multiply by the denominator on both sides. I'm going to put that in parentheses since there are two terms in that expression. That'll get rid of the denominator. And so I have x plus 1 times y equals 3. You certainly could distribute, but remember my ultimate goal is to get x alone. And if I distribute, I'm going to have it xy plus y. So you can do it this way. Whatever you want to do, just get x alone. My method of getting x alone is just go ahead and divide. Here we go. Divide both sides by y. And you have x plus 1 equals 3 over y, and then you subtract 1. But you can do whichever method you want. So I'm going to write that in inverse notation. And there it is. So let's talk about the domain range. This should go back to the first lesson. If you see any sort of division, you always have to watch out for domain restrictions because remember we cannot divide by 0. So here's our denominator. Remember the denominator, in this case x plus 1, cannot equal 0, meaning x cannot equal -1. So this was the function. So for the function's domain, I'm going to say x can't be -1. But remember, the domain of the function is also the range of the inverse, so x can't be -1 right there. Then I'm going to go to the inverse. Our inverse, the only value in the denominator, is y. So we just know that y can't be 0. So I'll go ahead and say y can't be 0, and that will also be the range of the function. All right, here's another tricky one. This time it's a little harder just because there's that x on top in the numerator. But rather than going through the domain and range, I'm just going to go ahead and show how to solve this. Or at least that'll be my main focus. So once again, multiply both sides by the denominator. Since there are two terms, I'm going to put that in parentheses. And then this time, if I just keep it 4 minus x times y equals x, if I divide both sides by y, I'll have 4 minus x equals x over y. So there will be x's on both sides. You can solve it that way, but I'm going to go ahead and do another process where I will this time distribute. So if I distribute, I get 4y minus xy equals x. Remember, we're trying to get x's alone, so I'm going to move all the x's to one side. So I have 4y, I'm going to add that xy over, equals xy plus x. And then we're going to factor, because both of these terms right here have an x. So I'll have, 4y equals x times y plus 1. And now I can divide by y plus 1 and get that x alone. So we have x equals 4y over y plus 1. So domain, if you're going back to the original, x can equal 4, which means the range of the inverse can equal 4. And then for our inverse function, which I should have written out in function notation, is y can equal -1.